Okay, welcome to lecture number 41. In 41 lecture, there is only one problem that we are supposed to solve. The problem statement is 25 points in a square configuration, and you can see the diagram that we have joined almost every possible line segment. X, W, Z and Y are midpoints of the sides. ABCD is a square and diagonals, everything is joined. Now they are divided, the entire square is divided into 40 small triangles, right? And now a couple of things that we need to do is, basically what we need to do out of this square is we need to find out length of every segment, every small segment present in this diagram, and area of every triangle that we see in this diagram. This is the task. Now to make the task little easier, first thing that we need to know is WD, ZB and BD. WD, ZB and AC. These three lines are concurrent, they pass through E. We need to think and find out why should they be concurrent. If you happen to draw this diagram in your notebook, you will also get these three lines BZ, DW and AC concurrent, passing through common point E. And you think about its reason, it is very easy to find out. As a Z is midpoint, W is midpoint, it is obvious that they are concurrent. Okay, the reason is basically these three are medians. AV, BZ and DW are medians of triangle ABD, and therefore they are concurrent. And now they give us the information that this point E is dividing basically AV in the ratio 2:1, the ratio of medians, and therefore VE upon EA, which I have drawn here separately, VE upon EA is 1:2. This ratio is 1:2. Now F is a midpoint, therefore this is 1:1. That also we know. Now because of this concurrency and symmetry of the figure, we have everything similar. Now one more thing that we will require to prove is that this line AX, the line AX is perpendicular to line DW. AX is perpendicular to DW. Why do we do that? Consider triangle AZB congruent with triangle AZB is congruent with AWD. Okay, so AWD is congruent with AZB. Why? By SS. And therefore this angle X is going to be congruent with this angle X. Is that right? And this angle, which triangle? AZB. So this angle is going to be Y, and X plus Y is 90, will be congruent with am I considering correct triangles? Oh, okay, let us consider, we want to show this angle 90 degree, AX and DW. So triangle ABX is congruent to DAW. Okay, so ABX is congruent to DBW. So let us call this as X and this as Y. Then this is X and this will be Y. Okay, and X plus Y is 90. Therefore at angle ANW is going to be 90. So ANW in this diagram is also 90. So this is how. So now if instead of doing 40 different triangles, dealing with 40 different triangles, we can deal with only 1/8 of the total square, and we have 5 different types of triangles in this. And if we find out areas and lengths of these triangles, we will be able to say that we have solved the entire square. And hence now we will deal with only 5 triangles, their areas and 5 different lengths. Okay, So now it is given that the length of the square is AB, therefore AW is going to be equal to AW, let us list, is going to be A by 2. AW is A by 2, right? WF is going to be A by 4. WF is A by 4. VF is also A by 4. This is also A by 4. Now, if this is A by 2, so this total is A by 2 and this total is A by 2. Therefore, AV square is equal to A by 2 square plus A by 2 square, which is Pythagoras theorem, which is A square by 4 plus A square by 4 is A square by 2, and hence AV is equal to A by root A upon, is it correct? Yes. So AV is, AV we can write as A upon root. Okay. Now how much is VE? VE is 1:2. This is the division. Therefore 1 upon 3 times A upon root 2. How much is AE? How much is AE? AE is 2 upon 3 times A upon root 2. So we have done this, we have done this, we have done this, we have done this, we have done this. Correct? Now, which one should we do? Okay. Now, when we proved this right angle triangle, now, then because this is 90, now we will say triangle AWN is also similar to triangle AXB. Because A is a common angle and N is 90 degree. Here A is a common angle and B is 90 degree. Therefore these two are similar, and hence what we will get is the ratio of the sides AW upon AX is equal to WN upon XB is equal to AB upon AN. AN upon AB. AN upon AB. BX WN upon BX is AW upon AX. Is this correct? What I am trying to do is yes. So BX upon AB. So if I use these two, then what will happen? WN upon AN is equal to BX upon AB. But BX upon AB is 1:2. This is 1 upon 2. This is half and this is full. Therefore, WN upon AN is 1:2. So WN is 1 and AN is 2. 1:2. So WN upon AN is 1:2. Now if you observe that if this is 90 degree and this is also 90 degree, then this is complete Pythagoras theorem configuration, and hence if I can find out that okay, this is 1:2 here, we did not have to do this. WF upon WA is 1:2, therefore WN upon AN is 1:2, therefore ANF upon WN is also 1:2. Maybe I will write that is better. Okay, so in this triangle, basically complete similarity last lecture contained. Triangle AWF is similar to triangle WNF is similar to triangle AWF. So small 90 large, so A N W. So if we write the ratios, we will see that 1:2 are the two sides of each triangle. Therefore WN upon NW is equal to 1 upon 2, and similarly NF upon WN is also 1 upon 2. So if we use these ratios now, we should be able to find out Wn and An. How? A by AW square, that is A square by 2, is equal to Wn square plus An square. But Wn upon An is equal to 1/2, and Nf upon Nw is 1/2. Okay, so Wn is equal to half An, or maybe we can say An is equal to 2Wn. So Wn square plus 2Wn square, which is 5Wn square. So Wn square is equal to A square. Wn square is equal to A square by 10, and Wn is equal to, therefore Wn is equal to A upon root 10. Bit involved but doable. Wn is equal to A upon root 10, and An is 2 times this. So An is equal to 2A upon root 10. Correct? And now what we are left with is Nf. Nf is half of Wn. So Nf is A upon 2 root 10. Correct? And now if we know Ae, if we know An, we can find out Ne. You can do that. And once we know Ne, we know Nf. By Pythagoras theorem, we can find out Ef. So practically we could find out all the possible lengths in this diagram, and we should be able to complete it. Because we know Ne, we want to find out Ne now, but we know Ae, it is written somewhere here. A is known, An is known, and therefore Ne can be found out using Pythagoras theorem. This angle is 90. Now if Ne is found out, Nf is known, Ne is known, therefore Ef can be found. Okay, so this is as far as finding out different sides are concerned. Now if the area of this square is A square, because side is A, then 1/4 of the square will be A square by 4, and half of that this triangle is the triangle AWV has got area A square by 8. Is that right? A square by 8. Now I don't have space, but let us make it here. Area of AWN is equal to A square by 8. Now we know 1:2 division, therefore area of WVE upon is equal to 1 upon 3 times A square by 8 AWN. What am I writing? Not AWN, AWV. This is AWV. Then area of this triangle is 1/3 of total. Area of AWE is 2/3 of total. 2 by 3 A square by 8. Correct? Now we know these distances also, 1:2. So WVE is divided in the ratio half and half. Therefore area of triangle FEV is 1/2, 1/3 A square by 8. This is done. Okay. Now again we know this ratio Wn upon Ne, Wn upon Ne ratio we will know when we find out distance Ne. So if we find out distance Ne, we can really find out Wn upon Ne, and now this total area is AWE, which we have found out. Total area WFE is equal to this, because this is midpoint, we can divide these total areas in the ratio this as to this, we will get area of this and area of this, similarly area of this and area of this type. So that is how we are supposed to solve entire square. This is not difficult, this is long, this is meticulous, this requires some systematic approach. We have to do everything very accurately and slowly with understanding. If you do it, you will be able to develop the entire set of answers independently. But I hope you have understood what we have discussed. If not, you can repeat the video and understand it. Okay, thank you.